Okay, so now today we are going to talk about mobile IP, and some of this may be repeat for those of you who took 473 last semester. How many of you took 473 last semester? 1, 2, 3, 4, 5. So we are going to go quickly through this because it's a little bit more detailed than last time, and actually all that is required for the next part, which is the mobile IP part 2. And so we'll talk about mobile IP terminology, process, registration, security issues, tunneling, and then what is the effect of dynamic IP addresses? Dynamic IP addresses are the private addresses that we use nowadays. And actually, they're not all private, but dynamic means they're assigned on demand. And then we have dynamic home agent assignments. So this is more detailed. Actually, the first maybe one or two slides are common with 473. So basically, what mobile IP allows you is that you take your computer from one room to the next room, and you do not get disconnected as you change the routers, not the base stations alone, the routers, because this is the level 3 handover. Right? Level 2 handover is very easy because in level 2 you don't change your IP address, and therefore the TCP connections don't know. But the level 3 is difficult because the TCP uses IP address for the connections. So all your applications, when they're connected to a particular IP address. And if your IP address changes, all the applications disconnect. So if you are doing any video session, if you are doing any FTP, or VPN for that matter, anything you are doing will disconnect as soon as your IP address changes. And therefore, we need something from IP, and that is called mobile IP. And so we use this example in 473, and I'm going to again, the best way to introduce mobile IP is that when you are very mobile, what you need is a secretary at home, office, who can answer all your phone calls. And so basically, people still call your home phone number or office phone number, and they are answered by the operator who transfers your call to the place where you are in a hotel or wherever you are. So somebody tries to reach Mr. Smith, who is mobile, and the phone, so they don't know that Mr. Smith is in Washington or wherever they are, so they call the home number, and then the home number picks up, somebody picks up at home and send the call to wherever you are, hotel. And you go as you move away from hotel to hotel to hotel. This only person who knows where you are is the home operator. Alright, so there are two operators, hotel operator and home operator. So the hotel operator is what we call foreign agent, and the home operator is what we call home agent. This is the correspondent, and this is the mobile node, right? So that's the terminology we use in mobile IP. Correspondent node send the packets to the home office, which is the home address, and their home agent picks up those packets, right? And then send them to foreign agent who sends them to mobile node, and as mobile node goes to some other place, they pick up another foreign agent and they tell the home agent that I'm here. That's the whole technology, is that you have two routers actually, which we call them home agent and foreign agent. These are the two routers who pick up the packets. So this one picks up in the home area, and this one, and then sends it to the foreign agent, and then it sends it to the mobile node. All right. So some of you can get, but how many of you have heard of the pair of address before? So those are the 5 people who took 473. So please listen carefully because this is a repeat for some of them. We just had this in the last semester. At least this part. So basically, this address of the foreign agent is called care of address. So this is like a hotel number. So you tell your home agent that this is my hotel phone number, and all the calls are sent to that number. And it could be actually a room number in some cases, where you really don't have an operator because the phone, when dialed, if somebody dials that number, it rings directly in the room, and then in that case, the care of address would be right into the mobile node. So the care of address does not have to be foreign agent. It could be right, with the mobile node. The care of address is the address where the packets are sent to, and that could be at the mobile node, or that could be at the foreign agent. And the home address is the address to which the packets are originally sent by the correspondents, and that's the only address people know. And so the home agent picks that up. So there are these terms we have used: home address, IP access address. So now IP access address is different from the home address. What is the IP access address? It is the local address of the mobile on the foreign network. So let's say I'm here in Washu, and all our addresses that are given out are 128 or something. Right? So if I have a computer here, I will get an address 128 or something. But if I move out to a hotel, my address might begin with something different, which could be most likely 190 to 198 point something. Right? So that would be my IP access address. That is the address that I will use in the foreign location. My home address is still 128 point something because everybody, when they try to find out, in this case, let's say my computer, when they resolve to it, DNS gives them the address here. Right? So that is the difference between okay. So that's the address care of address. What is the care of address? We already talked about. Care of address is the IP address where the packets are sent to. Now this is slightly different than the access address. So I may get 192 in the hotel, but 192 is actually not a public address. It's a private address. So you cannot send on the internet packets address to 192. Right? So hotel has one public address, so all the packets are first sent to the care of address. Right? At the care of address, then they can be sent inside the public address, private address. Right? So that public address which is used to send the packets on the internet is called care of address. Mobility agents are both home agents and foreign agents and mobility agents. Advertisements, both of them have to advertise periodically, advertising their services, saying that I'm a foreign agent or a home agent, so other people can connect to them. And correspondent nodes, any node who wants to talk. Foreign network is, as we said, the network that you're visiting. And virtuous ARP is sent by the home agent to update other nodes ARP cache. So how does the home agent pick up the packets? That's another magic, is that packet is sent to my computer's address, and somehow the router picks it up. How does it pick it up? Well, the way we send IP packets on Ethernet is using ARP. First, we find out what is the Ethernet address of this node. Right? So, if you want to find out the Ethernet address of my computer, you will get first the IP address of my computer using DNS. Then you will send a broadcast message saying that what is the MAC address of this IP address? Right, so anybody can respond and say, well, I know the MAC address for this address is, now ARP does not have a server like DNS server. So it's a distributed request. It's a broadcast request. We ask everybody, and generally the computer which has that IP address that can respond saying that, well, my MAC address is such and such. So when you want to send a packet to that on Ethernet, you take the router takes the packet, puts it into an Ethernet frame, and puts the Ethernet address and sends it on the Ethernet. And that node can pick it up using the Ethernet address. So that's how the packets are picked up, is by the Ethernet address. So virtuous ARP is basically the same thing, is that when somebody asks, does somebody know, Jain.20 or whatever the computer name is? So the router answers that, saying that yes, I know, and here's the address. Gives its MAC address as the address. So all the packets to Jain.20 are now sent using the MAC address of the router, which is actually the home agent. So everybody understand what is this, how the ARP is used? in getting the packets to the router rather than to the when the node is not there. Because if the node just left and the packets will be sent to the Ethernet address, they will not be picked up by anybody and the packet will be lost. So instead of that, the router gives its address as having the IP address, its MAC address as having the IP address, and then now the packets are picked up by the router's Ethernet card, and then it knows that this is, for me to send it to somebody. All right. So these are the key things to know. More mobility binding. So what happens is then a connection is basically set up in some sense between the home agent and the foreign agent. Actually, the home address and the KF address. That is called mobility binding. Every time the KF address changes, a new mobility binding takes place. A tunnel. So what they do is to send the packet from one place to the next, they take the old packet, full packet, including the IP address and everything else, put it inside another IP packet, encapsulate it to IP to IP, okay, and then send it to the KF address. That is called a tunnel. Okay, encapsulating the packet, an IP packet inside another IP packet, and sending it as an IP packet. That is called a tunnel. So that is the path followed by the encapsulated packet. Mobile router. Now we haven't talked about mobile router, but we are talking about mobile node so far. Mobile node, which is the one that keeps moving from room to room. But can you think of a situation where the routers will move from room to room? Think of a bus or a plane. So if there is a router on the bus is going, on the street, it is going basically moving. It's changing its point of attachment. And then everything who is on the bus, everybody on the bus has a computer and all that. Those are all the computers that are connected to that router on the bus. So the whole network is moving. That is called mobile network. So mobile network node, any node on the mobile network is mobile. Now that node actually is in a mobile network. Mobile network node is slightly different from mobile node, that the mobile network node may not be moving by itself. So it is, suppose that a computer on the bus permanently fixed. It doesn't move, it doesn't get out of the bus. But it is part of the mobile network because the router keeps moving. When the router keeps moving, it gets new network addresses. It gives out new network addresses to the, and somehow it manages all the traffic. So that is a mobile network node, could be permanent or visiting. And then roaming. Roaming is more of a agreement between the networks. So if you go from one network to another network and the other network allows you to connect and get all services done, simply because they had some financial arrangement with the previous network saying that we will take your people, give them the connection and take their traffic. So that is a roaming agreement. So it's like just like we talk about cell phone roaming, you could have IP roaming. In fact, if you go abroad and if you have some service here, let's say AT&T or something like that, internet service I mean, and DSL service, then you go abroad, they might let you use their network over there simply because AT&T has a roaming agreement with them. Okay? We are finding less and less of that these days. But there used to be a time when we used to subscribe to an international plan where we could just connect. Actually, it used to be dial-up days. I remember it was dial-up days. Every city you go to, you have dial-up a local service provider, and those ISP had roaming agreement with our dial-up service provider here. And so we used to be able to dial up in any city without having to set up any account. So that is roaming. Okay. Any question about any of the terms here? More. So handover basically is changing the point of attachment. And there is L2 handover and L3 handover. L2 handover is just changing the L2 address. L3 handover is changing the L3 address. So if you change your L2, if you just take it from here and put it there, connect it over there, but if your IP address does not change, that's an L2 handover. If your IP address changes, simply by taking the plugging from here and plugging it over there, IP address changes, that would be an L3 handover. Yeah, question. Yeah, you must probably have an access point along the router. See, the thing is, access point job is different. Access point job is to provide the wireless connectivity. And so you could have a wireless connectivity, or you could have wired connectivity. I mean, they could provide a plug on the seat, so that would be wired, or they could provide a wireless. That's totally different connectivity. In spite of all that, if you are going to be moving from, so you might need a router for many reasons, and the thing is that the one main reason is that when you go along these different places, they may not have the same, they may not have the same IP network. Okay, so, and one place you're part of the WASU network and you have 128 address, and you're part of some other network which has 127 address, and so on and so forth. So as something moves, it is changing its point of attachment at layer 3. Right? On the other hand, if you're on a cell phone network and you're moving this from tower to tower to tower, all those cell phone towers are connected to a single router, then you are probably not changing your IP address. So that would be L2 handover. On the same bus. Right? But generally, I mean, is that you will probably change the layer 3. You got a point which I was going to bring at the end of the lecture, but I will bring it up now. So cell phone networks don't yet use IP. I mean, they are starting to use IP, but when you go along the cell phone and do on the highway and all that, whatever you're doing, really you're not using IP. Okay? Even in the background, they just have, they have, first of all this digital technology we talked about, right? So this 3G, 2G, 4G, they take it and from there they probably put it on a phone network where they still go as bits, and to the other end where the phone network is delivered as without any IP paths, right? Circuit switch connection. Now that is changing. Much of it is now becoming IP at some point, right? And so you really, when you're doing a communication on the road today, I don't know whether you really get an IP address. You probably don't even get an IP address, and you just connect to the base station and base takes your base. And it goes to some place where if it has to run an IP network, they will have an IP address and they will send to some other place. So that's very different technology. Yes. So that is mostly L2 handover. And the example you gave here is also L2 handover. If you take this computer from here to the outside, it will probably remain connected even though the access point has changed. But if I take it from here to my office, it is going to get disconnected. Okay. So one of the frustrations of mobile IP has been that mobile IP have been teaching for 15 years. Just like IPv6, they've been teaching for 15 years. And it is implemented. So if you go to Cisco, they're selling routers with mobile IP. But I haven't found one. So when I go to the hotel, I don't see anybody advertising foreign agents, local agents, all here. So this whole thing has been somewhat of a disappointment in the sense that mostly we do L2 handovers, but not L3. But the technology is there. And They're still teaching it because we hope that when the cell phone people move to IP, which they are moving in this generation, fourth generation is all IP network, they will use this technology. All right, and so that's why so the thing is, I'm going to talk about proxy mobile IP. This is actually what is being talked about in 4G. Okay, so this is a technology which is, like IPv6, there's nothing wrong with IPv6, and I could give a lecture on what is wrong with IPv6, but basically the idea is that IPv6 is here but not here. Similarly, mobile IP is here but not here. It's implemented, and if you go to Cisco website, they tell you how to program the router for mobile IP, this and that, everything. But have I seen one? No. Alright. Coming to L2 and L3 handover. There are two handovers, and this whole lecture is about L3 by the way, right? And then we talked about horizontal and vertical handover before. So this is a repeat. Anybody remembers what is a horizontal handover? Huh? Horizontal handover. Same thing like this is for the test tomorrow, right? So if you go on the same technology, such as, for example, give me an example. Yeah, so that's a horizontal handover. You are just not changing the technology. If you go from Wi-Fi to Wi-Max, that is vertical. And push handover and pull handover. Push handover means the previous router initiates the handover or previous access point, actually there too. And pull means the new access router initiates the handover. So push means you are pushed to the new network, pull means you are pulled by the new network. Yeah. Okay, all right. So you use a new term, which let me ask. Okay, so you said hard handover. So we had also defined actually in our previous class soft handover and hard handover. And anybody remembers what is a soft handover and what is a hard handover? Yes, that is make before break. Sorry, just the opposite, I'm sorry. Soft handover, hard handover would be the break before connecting. Okay? Soft is when you don't break. So the idea is that handover could be soft or hard. That again depends upon when it is Wi-Fi to Wi-Fi. It could be soft or hard, depends upon how the access points are connected in the back. So the thing is, so it's not necessary that all Wi-Fi to Wi-Fi handovers could be soft. They could be hard, they could be soft. And that is actually the term here, make before break and break before make. So we already talked about those two. Then handover delay, the time between the break and the make. So how long does it take, right, to break it? And smooth handovers, this is soft and hard. Smooth handover minimizes the packet loss, handover delay not critical. So now, smooth is hard. So it is not the same thing as soft. Smooth is that there is a break, but the break is very short. Alright, so it minimizes the packet loss. So here the count is how many packets I lose, and nothing else. If you don't lose too much, then it is smooth. Or if you didn't do at all, that would be smooth too. Basically, you got disconnected, but you didn't lose anything because the packet was kept at the other place. So when you get there, the packet was given to you. So that is, like that. Fast handover minimizes the delay. So this one is not so much concerned about the number, but it is about the time. And seamless handover is basically where there is no change in quality, security, or capability of service. So basically, you don't even feel like you will change at all because whatever quality of service you had, whatever security you had, capability you had, throughput you had, everything remains the same That is seamless handover. But I'm defining all these terms because these are defined in a particular RFC. So people, when they start thinking about mobile IP, the first thing is that let's standardize the terminology. So that when I say smooth, you know what I mean. When I say hard, soft, So these are all defined. In fact, I have somewhere the reference, maybe at the end, for the RFC, and this whole RFC is on the terminology. It could be either one. Okay, so now let's think of a smooth handover that is break before make. Okay, and I want to do it smoothly. So what I will do is we will break the connection, and the packets will be saved at the new place. So you don't have a connection for a second, 2 seconds, 5 seconds, 10 seconds, however long it takes to connect there. But as soon as you get there, your packets will be delivered to you. So the loss was minimized. Packets can overflow and then packets can get lost, or packets may not make it to that place and packets may get lost. But that is smooth handover, even though it was that was break. What was that? It was break first. Right? So these are all independent. You could have something, and the term smooth is kind of, so smooth and soft and fast and seamless, they all different meaning. Right? Smooth means loss, fast means delay, seamless means quality of service. Diversity means it's like multi-homing. You will be able to connect two signals at the same time. If you allow diversity, then you are really allowing two connections at the same time. So you might have two antennas, or you might be able to receive two signals, Wi-Fi and WiMAX at the same time. Micro-diversity is the two signals between the same subscriber and the base station, two signals between the same subscriber and the base station. Macro-diversity is two signals from different base stations. So when you do MIMO, that is which one, micro or macro? Yeah, that is micro. So that is basically you have two signals between the same base station and the same user. Whereas if you talk to two different towers, that becomes macro. IP diversity, you have packets on two different IP networks. Micro mobility is the mobility within a single network, so no effect on the outside, for example, local mobility, and macro mobility means mobility between the networks. So that requires mobile IP. Every time you have macro mobility, you do need IP solution. Right? Alright, so I defined a lot of terms. And actually, this is not the whole set. There is a whole RFC, which is several pages long, which defines everything to do with movement. Alright, so now we go into agent discovery. How does mobile IP work? So first, we need to find the home agent and foreign agent, and for that there are two methods, and this is true for any other agent finding process, is that either you advertise or you probe. Advertising means that the agents will advertise, send out broadcast packets every few seconds or minutes saying that I provide home agent services. Probe means you send a request, you broadcast a request saying that is there a home agent in this area, and you broadcast that request, and somebody will answer saying, yeah, I am the home agent. I can serve as your home agent. So those are the two methods. Just keeping movements. Okay, so home agents and foreign agents advertise periodically on the network layer and optionally on the data link. They also respond to solicitations on the mobile node. So mobile can send solicitation to multicast group address. So this address 224.0.0.11, this has been reserved for IP multicast. Sorry, IP home addresses. So this one says to all IP home agent, all IP mobility agents. Right? So when this packet is sent, it is picked up by all IP mobility agents. And mobile selects an agent and gets the care of address. So then you select one of the agents, and that agent will give you the care of address. Registration, then you send a packet to your home agent and say, well, here is my care of address. You can reach me at this hotel at this number. That's kind of message. Home agent sends a reply to the care of address, and then it confirms that, yeah, I got it, and then the modality binding has the negotiation time liveness. So every time you set up such a thing, you also say that I will be here for 2 days, or 1 day, or 2 hours, or 1 hour. And so for that language is done, after that you have to send another message saying that I'm going to be another 20 minutes, I'm going to be another 2 hours, and so you can keep increasing lifetime. And finally, the lifetime may expire, and that's the end. When you return to the home, you deregister to the home agent so that it sets the care of address to the permanent address. Then there is no care of address. Basically, all the packets you have to pick up yourself. Basically, to deregister, all you do is to register with the new address and set the lifetime to 0. When the lifetime is 0, that means I'm permanently here. Deregistration foreign agent is not required, and simultaneous registration with more than one COA is allowed. So you could have 2 care of addresses because you're moving from one to the other. You could have 2 care of addresses, and so the calls or packets will come to the first place, and they will come probably to both places, and then wherever you are, you pick them up. So tunneling, the way it is done is that this is the correspondent. It sends the packet to the home address, which goes to the home agent. Home agent takes that packet, sends to the care of address, and the care of address sends those packets to the mobile host. Now, all this time, the packet has the address of the home address, right? So what do we do with that home address? Well, we take the whole packet, which had the home address as the destination address in the IP. We take the whole packet with the destination address included, and source address and everything else, and put it inside another IP packet. So we take a bigger envelope, put a little envelope inside it. And on the bigger envelope, we write down the IP address destined to care of address. Right? And send it over there. And so this packet will make it on the internet. It will be delivered to care of address. At the care of address, it will be open because the header will tell it that this is a mobile IP packet. So it is not really for you, it is for somebody else. So they will open the envelope and find another envelope inside it. They will not open that envelope, they will just give that envelope to whoever it's supposed to go. So how does it know how this will be? Now remember here, this envelope has the address which is really not on this network. But it doesn't really care. What it says is, I know that this is IP address not on this network, but I know this guy is on our network, so it takes his or her MAC address, makes an Ethernet packet, and sends it to him or her. Right? So in spite of the wrong IP address, it gets delivered to the right host. Right? Because it is being sent on a local network. Right? With that address, it will never make it on the internet, but it can make it inside a subnet. Right? So there are 2 things that you have to know as to how come the home agent can pick up the addresses, and that magic is what? Why home agent is able to pick up the messages addressed to somebody else? Because of what is the protocol? Anybody? What protocol allows the home agent to pick up mobile host packets? We just talked about that, that message request is sent, and the home agent responds. ARP. So the ARP is used here. Here there is no need for an ARP because the care of address already knows. When you register with them, it says, this is my MAC address, this is my IP address. Right? So when you get a packet from my home, please send it to me. So this packet with the same IP address, etc., is sent on this network. This is an Ethernet network, right? With the correct MAC address. Everybody has to know the difference between MAC address and IP address and how this makes it, right? Yeah. Go ahead. Both the examples you gave are great examples. So a laptop is a mobile node. A cell phone, if it has IP, is a mobile node. So many of the cell phones started having IP now, right?
So this is sort of, I guess,
okay, so you are talking about femtocell, which we haven't talked about here, but when we come to femtocell, that could be one example where you could be moving, changing your IP from outside to inside rather. So that would be one possibility. So the idea is that anytime you change, you go to a network which does not have the same. So suppose you are in some subnet which has, how the subnet, how the IP network is defined by two numbers. First, they give you a subnet mask, right? 255.255.255.0. That is a subnet mask, and then they give you the first, and then they give you the IP address. But with the subnet mask, it tells you exactly which bits of the network part. So everybody in that network has that bit set, and then the host part is the rest of it. And so if you have that subnet part and you are here in the wrong place, then you're in a foreign network, right? Because you don't have the same subnet part for that subnet, right? So that's why you're in foreign network, but your packets are coming with that IP address. So the thing is, when you get the packet, there are two things required: that you should be able to get a packet with that IP address, and you should be able to send a packet with that IP address. Because when you send a packet with that IP address, some routers may throw away that packet. They will look at the source address and say, this source is not in our network. And it looks like somebody hacking. And so they will throw away the packet. So the foreign agent has to know that, no, this is not a hacker, this is live registered. Slide moved, yeah. Okay? Alright, so what is the tunnel? So this red line is the tunnel. This is the part, this red packet basically is an encapsulated packet. And since basically here, these routers don't really need to know anything about this. This router is a special router, this one is mobile IP. This router is a special router, this one is mobile IP. But these routers which are in between, they don't know anything about mobile IP. They just look at this address and forward the packet. So that's why we call it a tunnel. Tunnel in the sense that those routers don't need to know anything about this. It's like a direct path. Alright? So tunneling is same as encapsulation. Like when you take in packet and put it inside another packet, that is called encapsulation. It's also called tunneling because whatever the special fields might be in this inside packet, the outside people don't have to know that. The outside packet could be the old technology which does not use any new features. Now reverse tunneling. So the MN sends the packet directly to the correspondent with the source address is equal to home address and destination is equal to destination address. Such packets will be traveled with the network. Right? So the one solution is that you send the traffic to the home agent. So this is the mobile node. It sends the traffic with its foreign IP address as the source address, but it sends it to the home agent, and then the home agent changes the source address to the home address and then sends it over here. In that case, nowhere the subnetwork part is violated. Basically, you use the correct IP address here as well as you use the correct IP address there. Alright? So that means that this mobile node needs to set up another tunnel. This is red tunnel here in reverse direction. This is the reverse tunneling. Rather than sending it directly to the correspondent. This will be without reverse tunneling. Normally there is a triangle. The correspondent sends to the home sends it to the care of address and through the mobile, and the mobile sends it directly to the correspondent. So there is a triangle. But in this case, this link is broken. The correspondent sends to the home sends to the mobile sends it back to the home, and home sends it to the correspondent. So basically, I mean, the advantage of reverse tunneling is simply so that you are not violating the IP address semantics in any part of the network. Although that is very easy to overcome by simply knowing, for these routers knowing that this is a visiting node and therefore not a hacker, and therefore that address, even though it's not in some network, is fine. Let's just send it, right? So that's why I need reverse tunneling. So is reverse tunneling clear to everybody? Right? Alright, so we move on to the next problem, which is dynamic IP addresses. So dynamic and static, private and public. Everybody understand the difference between private and public addresses? Right? What is the difference between private and public address? Anybody? Public addresses are 10 or something? Yeah, private addresses are 10 or 192 or something like that. They cannot go on the internet. They are okay inside your private network. So in your home, generally you have 192 point something. That stays inside your home. When those packets go out of your router, they have a public address. Okay, then what is the dynamic and static address? DHCP server, yeah. And the static does not change. Static is the rest of the time does not change. Now inside your home, you could have a device that has a static private address. Right? What would be that device? Router is one. Any server actually. If you have a storage server, that would have permanent address actually. That is a static address. That doesn't change because if you change every day, you wouldn't be able to figure out. Or a printer, for example. If you have a printer, you don't want it to have a dynamic address. You would want to have the static address. Right? That static address could be public or private. So these are independent concepts. Not all static addresses have to be public or not all static are private, right? The static address could be both public or private. And similarly, the dynamic addresses. Dynamic addresses could be public or private. So for example, my computer in my office, every time I connect, it gets a new IP address. And since Bashu has plenty of public IP addresses, they give me a public IP address every time a new one. Right? So what I have is a public dynamic address. At my home, I don't have that luxury. At home, every time I connect, I get a new address, but that is a private dynamic address. Alright, public, private, static, dynamic are orthogonal. You can have any four combination possibility. Clear? Alright. So what happens if you have an address which is dynamic? Now how do you do your mobile IP? You don't have a permanent home address. I mean, you have a home address which is basically, so this is what happens. I'm inside my home and I'm sharing this public address with my 15 other computers. One IP public address, but the way it comes to me is like my router knows that the port number is such and such, it will go to this computer. Right? So whenever something comes from outside, they know which computer to give it to. So how do you do mobile IP with that? Well, there is one solution, which is actually a Cisco solution. And so the registration request to home agent include a request for configuration. So it's like a DSCP request. So when you send it to home agent, you say, look, I am, you send some authentication data that Jain and this is my password and all that. But I need an IP address. I don't have an IP address. A local IP address. An IP address that will be good in your network. So it will give me 192 point something or whatever number that is, right? So that is, and the registration reply includes the IP address, DSCP server's address, and DNS address. So everything that DSCP is done locally will be given to me over there in the hotel. From my home agent. Huh? Yeah, right. So the thing is, yeah, DSCP needs no really not big table. DSCP, every router has a DSCP server built into it that I've seen so far. I mean, every router that I've bought for my home has a DSCP server built into it. And so DSCP is, the router can act as a DSCP server, or it could be separate, doesn't matter. So in my home, for example, let me tell you the configuration. I have 3 routers, and 2 of them I have disabled DSCP, 1 of them has DSCP. All 3 have a DSCP, but I have disabled on 2 of them because I don't want to get, See, the thing is, whichever server gives you the DSCP address also makes itself the default gateway. So one strategy would be that you could just randomly take whichever line answers the answer. And so there are multiple lines, right, coming in. There's a cable line, there's a JSL line, there's this line coming in. So, and different speeds. So you want to connect to the highest speed. So there are some games you can play with the DSCP servers and routers and like that. So anyway, so I think that answers the question is that basically what dynamic addresses allows you is to get that dynamic address. So there is public or private, doesn't matter, from your home agent by this extension. There is a new message which you can send, registration message, to your home agent and say, look, I don't really have an address yet. Give me an address and register me. And now that has been published by you as an RSC. So that's what I'm talking about. It's not where I'm talking about Cisco. But that solution is probably accepted by the industry as an RSC. So it's already, so everybody just implements it. You can also get a home agent dynamically assigned. If you don't have a home address, how can you have a home agent, right? So a big company like Vashi is running lots of home agents, lots of routers. How do you get it assigned? Well, this is a method. You send it to any one of them. So you say a registration request to HA1. HA1 is home agent number 1. The foreign agent will send that request to home address number 1, and home agent number 1 will say, sorry, I'm too busy. Maybe you should go to home agent number 2. So it will say redirect to home agent 2. It will come to you. Then you send a registration request to home agent 2, and then the home agent will say fine, and you are success. So that's another RSC. So basically, you can dynamically get assigned to a home agent that means to a router in your home network, and depending upon who has less load or who you are assigned to. By the way, this process is similar to what we do on the IP redirect. Is that you have a default gateway. Whenever you have packet to send outside, you send it to default gateway. But if you have a multi-homed network, so there are multiple gateways, then your default gateway will say, no. If you really want to go there, please send it to that router. Okay, so there is a redirect philosophy there, so then you find the best path to every destination. And so the same thing is done here. Is the home agent, there are multiple home agents, you send a request to one, and you say, no, send it to the second one, and you send it to the second one. Okay. So is this clear now? How does multiple home agent work? All right, I move on to then the network mobility. Network mobility has to do the whole network moving. So think about a plane. It has a router which is moving in the plane, and there is a fixed node inside the plane. So what do? That is also supported, and it is called Nemo. Network mobility, NEMO. So there is a Nemo group in IEPF that is working on network mobility, and they have lots of RFCs. The key RFC, the first RFC here, 3963. And so the way this is handled is that the mobile router registers its prefixes with the home agent. So now it doesn't register in one address, it registers a whole set of addresses. How do you know whole set of addresses? The prefixes. What is a prefix? Basically, that is your subnet part of your address. So when you get an address, when we talk about that you have a subnet mask and you have the address, if you just add the two, you get the subnet address, right? So that part of the address which is just belongs to all the hosts in that network, subnet, is a subnet mask. That is your network prefix. Now you might have more than one network prefix because that router might support more than one subnet. And so it registers all those prefixes with the home agent, and when the home agent gets address packets for any of those prefixes, not just one address, any of those prefixes, it sends to that router, and then the router takes care of the rest. Alright? Is it clear how the network mobility is handled? What is the key difference between network mobility and the node mobility? In the node mobility, what is registered? With the home agent? Just you register your care of address and your home address also you give it to them, right? So you send two pieces of information, your home address and the care of address to the home agent, right? In the case of network mobility, what do you send? You send the set of prefixes. It's not just one address. You send the set of prefixes, and you possibly might have a care of address which belongs to the same router. In the same router, it might have a new IP address, which is where you will send it to. Every time it goes to some other place, it gets a new IP address. So the routers have actually two sides, right? The wide area side, the WAN side, and the local area side. On the local area side, they have these three networks which are basically flying with them, so they're not going to change anything on that side. On the wide area side, they're connecting to different towers, different companies. As the plane moves, it gets a new IP address. Right? So that IP address, which is your care of address, is registered along with the prefixes with the home agent. Clear? As to what is being registered, every time the plane moves, if the router finds a new address on the other side, right? On the attachment side. And that address is registered with the home agent router. Alright. Now comes security issues. Now this is a tough one because we haven't talked about security and that's the whole class. I think this level of security we had talked in 473, so I think I will try, if you remember your 473 security, is that we need to authenticate. Who needs to authenticate to whom? Mobile needs to authenticate with the foreign agent. Foreign agent needs to authenticate with the home agent, and vice versa, by the way. And then the mobile needs to authenticate with the home agent. So they each need to trust each other. They need to trust means they need to authenticate, make sure that that is the person who they are saying they are. So how do you authenticate? Well, we use a message. First of all the messages use, okay, so this didn't talk about the user authentication, but all the messages that are sent have a authentication code in them so that you know that the message is coming from MN, RFA, and then wherever they are saying they're coming from. And they use a MAC. Actually, this MAC is here for message authentication code, which is based upon MD5. So in network security, we talk about MD5, message digest number 5. There was MD4 before, but MD5 is the current one which is used. So that technique is used for message authentication. So how do you get the key distribution? So now for everything in security, we need keys, and so you have network key distribution, and then you need encryption, so IPsec, secure IP, and in secure IP you have two different methods, ESP and CA. I forget the CA or the CA. So there are two methods for IPsec. So ESP is used, and then replay protection. And basically replay so that the same packet cannot be sent again and again. Somebody else cannot just take your packet and resend it. For that, they put an identification field which is changed, or we use timestamp so that if the packet comes at a different time, we know it is a different time. Or a nonces. Nonces, anybody know what nonce? You don't know nonce now? We use it a lot in the heck? Huh? Okay, maybe we didn't do it in the 473, but we did it quite a bit in security course, obviously, and you have taken security course. But so that is not. I mean, basically, what that means is it will happen only once. OLCE, only once. Okay, so that is like a random number we generate, and then you don't use it again. Okay, so that is, you put a number like that, so you don't use that number. So those are things which are used for protection, either timestamp or nonces, and then you can put a sequence number, identification key. Location privacy. And so you don't want the, what is location privacy? Location privacy means you don't want the correspondent to know where you are. So if you get your packet in Washington DC, you don't want your correspondent to know that you're in Washington DC and in this hotel, right? And so that is, that obviously is what mobile app is all about. So in that case, you will not be using your correct source address at the foreign location, but you will be using your home address as the source address. And you may be required to use the reverse tunneling. The last thing is ingress filtering. Firewall graphs the outgoing packets with topologically incorrect source address, which is exactly the same thing as the reverse tunneling. So you need the reverse tunneling because your source address is wrong, right? So you put that into the correct source address and send it to the home address, and the home address will take it out and send the correct home address, and so on and so forth. Okay, so now let's see if everything got through. The purpose of this slide was to make sure that you understand that since you're in a foreign location, they need to make sure that you are the authorized person. So there is a lot of, first of all, user level authentication. Then every message has to be authenticated. So every message has an authentication code. And then it could be encrypted, and then we use IPsec for encryption, and then for location privacy, replay protection, and so on. So these are all the mechanisms. The thing is, if you know network security, then this is all very trivial stuff. If you don't know network security, I just want you to at least understand the concept as to what is happening with details to be understood when you go into network security. Then we should have some idea of what we are talking about here. So let me ask you, does everybody understand what is location privacy? David? What is it if I did something and that would be location privacy if I did, otherwise it will violation of location privacy. What is it? Give me an example of violation of location privacy. Okay, let me ask you. Sorry, go ahead, yeah. Okay, so let's say my home location is Washington, is St. Louis, right? And I go to I go to, let's say, Chicago, right? And somebody calls my office. Right? I want location privacy. This person, when calls the office, should they come to know that I'm in Chicago or not? Right? If they come to know in Chicago, then what happened here? That my location privacy was violated. Right? Location was no longer private. On the other hand, if there is no way they can still come to talk to me on the phone or on the internet or whatever it is, but they don't know that I'm in Chicago, that is what is called, I have achieved what? Location privacy. Alright, let me ask, what is the issue of ingress filtering? Ingress filtering, what is the problem here? What is the problem we are trying to solve? No? Is it clear to anybody? Okay, go ahead. Okay. Did that make sense to you what he said? See, what happens is the firewall inspects every outgoing packet. And in that inspection, they look at the source address as well. If the source address is not from that network, then they will not pass that packet.
So, using this, could you go over the reverse tunnel? So, that concept is understood, but how does reverse tunneling actually occur?
Okay, so what I want shown here is, so you see, in reverse tunneling, this, there is this one will send a packet which has the source address, which is a foreign address.
Right, so I guess the firewall.
But it is basically tunneling. Let me just tell you one more thing. It is tunneling, so then basically what the mobile node has done is, either by itself or by the care of address, which is in the foreign, there are two envelopes. The first envelope has the source address as the home address. That is put inside a bigger envelope that has the source address as the foreign address. Now that packet can get out of the firewall. That big packet can get out of the firewall. Why? Because it has the source address which belongs to that network. However, that packet is addressed to whom? The destination address on the bigger envelope is home address, home agent. Alright? So if we go to the home agent will take out the big envelope. And on the little envelope, what is the destination address? Huh? Is the correspondent address. No. On the little envelope, the destination address is correspondent. So it will be sent from the home agent to the correspondent. And again with the correct source address, and the firewall will.
Okay. So let's see that the firewall is expecting the source address to be the home address, right? But then since it's going to the mobile node, it sees another source address and it drops it back. Then how does reverse traffic occur? Does it automatically start the process? Like who does want to start it?
Okay.
And then it doesn't go any further.
No. Let me put a firewall in there, then it will be clear. No, actually there's no firewall there. Everything else is clear. But let me just put the firewall here. I think maybe it is easier just for me to do it on the board than maybe that. So there is a firewall. And this is a mobile node. This is the home agent. correspondent address corresponding with here. Normally, the packet should go right like this to the correspondent. Right? If this packet was sent, it will come here. The foreign firewall also not really look at the source address, it should look at the destination address and say it is going to the correspondent.
I think you should go foreign network.
This is foreign network. Right? This is how the packet should go. However, this packet will not go because the firewall will look at this home address and say this is not in my network.
So the problem here is when the mobile is trying to respond, not when the firewall receives.
Yeah, right. The problem happens in the response.
Okay.
The reverse traffic. Right? The packet when it came here, it was already into 2 big envelopes, right? So that went through, right? But when the packet is trying to get out, then it doesn't make it with this source address. So what we do is we put a data packet, and in this one we put the source address as foreign network, address to home network. So now this is correct source address. This firewall will say, oh, this is fine. But it is destined to here. This will open that big envelope, find this little envelope inside it, and then it will send from here that little envelope. All right. So now one more issue. VPN. So how can we have VPN? VPN, by the way, is also a kernel. So when I set up a VPN, for example, set up a VPN from home to WashU, what you're doing is you are taking all your packets, putting all your packets into another IP packet, IP inside IP, and sending them to IP router in WashU. Right? And from WashU, they are open, inside the WashU, they are opened and then distributed where they're supposed to go. Alright? So VPN is not just an encryption, but in addition to an encryption, it is an encapsulation. So that's a tunnel too. So if you have a mobile node which is talking through a VPN to a home gateway, home VPN gateway, so this is your home network, and you're talking to your VPN gateway, then you have a tunnel. This is the red tunnel. And this red tunnel uses IPsec. And then you have to have another tunnel to home agent because you're mobile. So there's a blue tunnel and there's a red tunnel. Now the problem is you can't have two tunnels because either you go packets this way or you packets go this way. If they go this way, they will never find the home agent. If they go this way, they will never find the VPN security. So you really need to have one or the other. Alright, so there is an RFC which solves this problem 4093. It lists 5 possible solutions to this. And I'll just tell you one, which is the most common one, is that you put basically home agent inside the intranet such that you can set up a VPN tunnel with the VPN gateway, and everything is your thing that is sending home agent is set as a packet inside that security tunnel. All right. So basically there is the mobile IP tunnel is inside the IPsec tunnel. So let's see how many envelopes there are. First of all, your original packets, they already have 2 layers of IP, the one layer and then outer envelope. On the top of that, you put one more envelope, which has the IPsec. So you will have the packets which are going through here, they will be destined to the VPN gateway, because that is that tunnel. The VPN gateway will take away that red envelope, throw it away, and it will find a blue envelope inside it, send it to the home agent, that is the address to the home agent. The home agent will take away the blue envelope, and it will find the envelope going to the correspondent, and will send it to the correspondent admin. So there are 3 layers of headers. Is that clear what it means when we say we have a mobile IP tunnel inside a VPN tunnel? That means every tunnel is an encapsulation, right? And so here there are 3 headers. Here there are 2 headers. Here there is only 1 header. I haven't shown that line, but there is a line here. Home agent to correspondent. This tunnel encapsulation is clear? Huh? You understand? Right? So this is one solution, is that you put anywhere, but it requires modification to mobile IP software. The mobile IP software has to know that it has to go through the VPN gateway. Another one is that you have both VPN gateway and home agent in one place, and then basically the mobile node knows nothing about this outside thing, and in this case it just sets up a VPN tunnel, which is the red one, and sends everything, but the foreign agent is smart enough to understand this part and sets up a tunnel with the home agent, a mobile IP tunnel. All the packets are sent to the VPN gateway where the mobile IP, this blue thing, is taken off, and then the red thing comes in. And if and generally the red thing might just even go all the way to correspondent. So this IPsec connection might be all the way to the correspondent. So actually I should probably show that. That will be better, because you don't do IPsec part way. You might do IPsec all the way here. So this is a fifth solution, and there are more solutions in that I'll see. That brings us to the end of this talk, this lecture. Again, the 5 points are that for the mobile nodes to work, basically they have to have a tunnel to the home agent, and from the care of address, and tunnel means at the care of address we put a new envelope, new header on it. And then in the reverse direction we may need a tunnel simply because the firewalls may otherwise throw out the packet. Second thing is with Cisco modification, we can dynamically assign the home address, we can dynamically assign the home agents. So we saw that possibility. We saw how the network mobility is supported, and network mobility requires, actually, there are 2 things which are required. One thing is that it registers the fixes rather than the addresses. And then obviously you need to reverse tunneling where all the packets go back to the home address. And need to carefully position VPN gateway and home agent so that you can do both IPsec and mobile IP. Now, in terms of reading, there is this Wikipedia article, there are a set of Wikipedia articles, some books, and papers. Actually, there was a homework I thought. Let me see if I can find the homework. Where is the homework? Right here. Okay, homework 18. So homework 18 has to do with the network mobility. A mobile node with home address in boostel.edu. So this mobile node, home address is boostel.edu, is traveling in a plane with a router that serves as a care of address. So now this is not a fixed thing inside the plane, but mobile. And this router has a care of address which has a home address of aa.com. Okay? The router is mobile and the address is aa.com. How many mobile IP tunnels will be set up and indicate IP address at the end of each tunnel? And so how does this work? Mobile inside a mobile network. Alright, now this homework is not due next Monday, I'll tell you why. This is due next Monday after that, but I'll tell you why. So Wednesday your exam, right? And then I had 1 week for you to write that paper, which is due on Monday. So because of the exam postponement, you probably have not worked on writing. I don't know, I hope somebody has at least done the writing part first. So I'm not going to ask that you submit this homework 18, this can wait for a week. Alright? So this homework is due a week from Monday. And I hope you will spend all your time on writing the paper. You know, if possible, I mean, it's from after Wednesday, even now if you can. Okay, so is that clear? Alright, I think the paper is due on 5th of April, if I'm right. And the date wise, I can't remember. Okay. Monday is 5th. Is Monday 5th? Right? So this will be due on 12th.